This lesson is the introduction to trigonometry, and we start with doing something called trigonometric ratios. It's a big word, but all it means is the study of triangle measures, and we're using ratios in order to solve for different side lengths of triangles. So to go ahead and define it, trigonometry, the study of triangle measures. Triangle measures, I'll use the symbol instead of spelling out the word. And then your trigonometric ratio, it's a ratio of the lengths of the sides of a right triangle. Kind of ran out of room there. A ratio of the lengths of the sides of a right triangle. Now, there are three common trig functions that we use. And this is going to sound kind of weird. But the first one is called a sine. And we use an abbreviation SIN, but please don't call it a sin because we're not in church. And a sine ratio is always a representation of a side opposite an angle to the hypotenuse. So we use trigonometric ratios in right triangles. And you know, if you have two sides of a right triangle, you can always find a missing third side. This is something a little bit different. Theta is what we use to represent an angle measure or a specific angle. And if we know that angle, and we know one side of the right triangle, then we can find the other sides based on that angle measure. So a sine ratio is taken from the angle, and we go to the side across from it. We call that the opposite and compare it to the hypotenuse. So if this is theta, if this is the angle that we're using, A would represent the opposite side, and C, of course, is the hypotenuse because it's the side opposite the right angle. So we would write our trig ratio as opposite over hypotenuse. Or in this case, whatever A is, that length, it would be our numerator. And C, whatever that length is, it would be our denominator. So what we're saying is if this angle was 32 degrees, every 32 degree angle in a right triangle would have a ratio that was equivalent to this one. No matter what, every 32 degree angle in a right triangle would have the same ratio of the side opposite to the hypotenuse. Now, what if we didn't know the side opposite? We might need to use this side right here, which we call adjacent. And we call it adjacent because if this is the angle we're using, this side is adjacent to that angle. Now, we abbreviate cosine as COS. And cosine is always the adjacent side to the hypotenuse. And don't get hypotenuse confused with adjacent. Yes, this angle is adjacent to the hypotenuse. It has to be. Okay? But the hypotenuse is always called the hypotenuse. Adjacent is a leg. So we've got adjacent over hypotenuse. So in this situation, the ratio would be whatever B represented, that number, to C. All right. Then the third trigonometric ratio that we talk about is called tangent, and we abbreviate that TAN. Now, the tangent ratio, compared to the angle that we're using, is always the opposite side over the adjacent. Opposite over adjacent. So I'm going to write that out. Opposite over adjacent. So A over B. And if this angle was 32 degrees, the tangent ratio of these two side lengths would be the same ratio of any 32-degree angle in any right triangle. Its cosine ratio would be the same. Its sine ratio would be the same. Doesn't matter how big the triangle is, the right triangle itself, because when you think about it, if we know it's a right triangle, we know one of the angles, and if we know this angle, then this third angle is always going to be the same in all other right triangles that we're looking at, because they're all going to be similar. If this angle was 32 degrees, then this angle is 32, 40, 50, 58 degrees. Therefore, this triangle is similar to every right triangle with those angle measures. So their ratios are going to be the same. All right. Why we use this when we use this. We apply this method using trigonometric ratios only to right triangles. And you always must start with looking for the angle. We have to have an angle to start with. Never use the right angle. Never use the right angle. It must be one of the acute angles. Now, we sometimes call this theta, and that's what that little marking is. It's called theta, and it's just like a generic term that we use when we're describing a specific angle. Now, you can use your graphing calculators to find missing sides of a right triangle, and here are your calculator instructions. The first thing you're going to do is clear your calculator out. So I'm going to throw this calculator up here and turn it on, and it looks like it's already been cleared. Second plus 7, here we go. Second key plus sign 712 to clear it out. And then it says change it to degree mode. The calculators are automatically in a mode called radian, and radian mode is something we're going to discuss later, but when we're talking about angles, we're going to refer to them as degrees. So I'm going to arrow down and to the right and hit enter, and now I'm in degree mode. So my calculator will understand the numbers that I put in for the angle measure to be actual degrees. All right, then I exit out of there. Now, to find sine, cosine, and tangent buttons on your calculator, right here, right above the 7, 8, and 9, 2 buttons up, is abbreviation for sine, cosine, and tangent. And when we're using trig functions, we're going to be using those buttons. So solve the given trig equation for x, then use the calculator to compute. So we're going to set some things up and then use our calculator to actually find the answers for us. And you must use, in order to use these trigonometric ratios, you've got to use these buttons. You've got to have a calculator that will do this for you. Now, find the value to the nearest 10,000th place. Well, the 10,000th place is 4 decimal places. 4 decimal places. Okay. Now, before we use the calculator, I just want you to practice setting these up. Okay, so we're just going to practice setting up our trig ratios. So I'm going to find the sine of theta. So my sine ratio of theta, this is my angle that I'm using. And remember, sine is the opposite over the hypotenuse. Opposite over hypotenuse. That would be A over C. And that's done. Cosine of theta, cosine is adjacent over hypotenuse. So I would use adjacent, which is B, to hypotenuse, B to C. And my tangent ratio is my opposite to adjacent. So my opposite is A, my adjacent is B, so A to B. So the main thing you got to understand to write these ratios is knowing what angle you're using, knowing that across from it is the opposite, the one attached to it is the adjacent, and then of course you've got your hypotenuse. And if you label that, sometimes it's a little bit easier to work with. But now if you look at the other triangle, now theta has moved. theta is in this position. So when I write my sine, cosine, and tangent ratios, they're not going to match these because now I'm dealing with another angle. And in a right triangle, this angle is probably going to be a different measure than this one, unless it's a 45, 45, 90. And in which that case, that's a special one, and we already know how to work the side lengths with that using the special right triangle techniques. So now we're considering theta here. So if I'm going to write my sine ratio, opposite is now side B, adjacent is now side A, and my hypotenuse is still side C. So sine for this angle is B to C. B to C. Cosine for this angle is A to C. And tangent for this angle is opposite to adjacent, so B to A. And when you compare these two models together, you can see that the tangent ratio for this angle is the reciprocal for the tangent ratio of the other angle. It's complement. The cosine for this theta, B to C, is the sine for this angle, B to C. And the sine over here is cosine over here. So it matters. So when we say it matters, you got to pick your angle, which angle you're going to use. You got to determine your starting point. That angle is your starting point, and you write your ratio according to that specific angle. All right, I think that is all we are doing for today as far as notes go. And when y'all come to class, we're going to be practicing using these ratios and actually using our calculator to calculate it all for us. Thanks, guys.